All right, here we have that we're going to be dealing with false positives in drug testing, and it says that many employers require that their prospective employees need to take a drug test. Seems pretty normal. Positive result on this test usually indicates that the prospective employee is using illegal drugs. However, it's not actually always the case because sometimes the test could be wrong. So according to this, it says that 4% of the prospective employees use drugs, and that the false positive rate, meaning that the people who don't use drugs and test positive, is 5%. So 5% of people who actually don't use drugs will test positive, according to this. And it says that the false negative rate, people who use drugs and test negative, is 10%. Okay, so we're going to construct a tree diagram to represent the situation. Okay, so now when you're making your tree diagram, make sure you start off by trying to keep the situation as simple as possible, meaning that try to break it down into as few possibilities, so as few events as you can. The more that you make, the more complicated it can become. So like, again, the way I always try to advise my students to go about this is look at in terms of, whoa, whoops, I'm really excited here. Look at it in terms of something happening and something not happening, and based on the problem. So in this case, we have that either you're going to be a drug user, so we'll have capital large Z, meaning that the employee uses drugs, or that they don't use drugs. They're drug free, you could say. Doesn't use drugs. Okay. Now what's the other thing? It's either that they can test positive or that they don't test positive. You could say they test negative in this case. So we'll have P, meaning that they test positive, and we'll have N, meaning that they don't test positive, so they test negative. And now we break it down. So look, what comes first? Well, what we're gonna always start with is that they're gonna either be a drug user or they don't, because not everyone technically has to take a test. So we start off with our branches being either that you're a drug user or you're not a drug user, drug free. And then each of these leads to you either taking the test and getting a positive result or a negative result. Positive, negative. So there's four possible outcomes. So this will be representing the probability that someone is a drug user and they test positive. So the probability of D and P. Here we got the probability that they take drugs and they don't test positive, or they test negative. Probability of taking drugs and testing negative. So D and N. And here the probability that they're drug free, they don't take drugs and they test positive. So F and P. And the probability that they're drug free and they test negative. Okay, so now we go and work our way into each branch and write down the corresponding probabilities. Okay, so we're told that 4% of employees use drugs. So they say, oh, suppose. So on this first branch, we're going to put 0.04. And then so 4% use drugs, that means 0.96, 96% don't, because these have to add up to 100, either you use drugs or you don't. Now let's read this carefully, because this is where it can be confusing if it's your first time doing these types of problems. Okay, so the false positive rate is 5%. False positive, so people who don't use drugs and test positive. So people who are drug-free, we're talking about here, and they test positive. So false positive, this is our false positive, because if you're drug-free and you test positive, that's wrong, that's incorrect. So that's gonna be 0.05. And that means that if you're drug-free and you test negative, which is the correct result, will be 0.95 because there's 95% left over, 5%, 95%. Now it says a false negative. So people who use drugs, so we're over in this world, and test negative, use drugs and test negative is 10%, so 0.1. That means people who use drugs and test positive is 0.9. Okay, so now we go ahead and figure out the N probability. So the probability of being a drug user and testing positive will be 0.04 times 0.09. We are going to use these corresponding branches. Or not 0.04 times 0.9, not 0.09. And you should get 0.036. For this one, the probability of being a drug user and testing negative will then be 0.04 times 0.1. .000, 0.044 or 0.004. And over in this world, we got probability of being a drug-free and testing positive. So 0.96, 0.05. You should get 0.048. And then for the last one, being drug-free and testing negative, 0.96 times 0.95. And you should get, let's see, 0.912. Okay, so here's our tree diagram. Now, this is really going to help with the rest of the problem now. So what percent of prospective employees will test positive? Well, remember, we look at the total outcomes here. Which one of these are showing that the employee tested positive? So here we got a positive. This is a positive result and a positive here. So these two values added together will be the probability of them testing positive. So the probability, I guess probability of P, will be 0.036 plus 0.048. I'm going to get 0.036, 0.084. Their answer would then be 8.4%. Now, what percent of prospective employees who test positive actually use illegal drugs? Okay, so this is a conditional probability we got going on. Okay, so we're given that the condition is they test positive, and we're trying to figure out what's the probability that they use drugs. So the probability of D, is that's what we're trying to figure out, given that they test positive. So the probability of D given P, the probability of them using drugs, of them being a drug user, given that they tested positive. Now, remember, this is just a conditional probability, and you could always refer to your formula sheet because they let you use this on your AP exam, and I'm pretty sure more in most stats classes, in case you forget. So remember, just A, and if this is just your A and that's your B. So the probability of them both occurring, the probability of D and P over the probability of P. So the probability of D and P would be this guy right here, because that's probability of using drugs testing positive, so 0.036 divided by the probability of testing positive, which we found up here to be 0.084. And we should get 0.036 divided 0.42857. So we could say about 42.87%. Yeah, so this is actually real data taken from a real study. And so this kind of if you ever hear about people who challenge their their drug tests, is because this is pretty high. This is a pretty high, like it's a pretty high rate. If 42% of them only use illegal drugs, that means like there's a lot of people that are being falsely accused. So something to know.